U.S. Geological Survey reports a 5.0 magnitude quake hit the last week in the Texas Panhandle. That's one of the strongest quakes we've ever seen in our state.
Texas is not known for major earthquakes, yet a sudden magnitude 5.1 quake shook a quiet ranching region and was felt hundreds of miles away.
The earthquake happened early in the morning, just after 5 a.m. Some tell us they felt their homes shaking. Others say they didn't even notice. It hit right next to the Texas-Oklahoma border.
Even more unsettling, the fault behind it may be connected to a half-billion-year-old scar buried deep underground and linked to one of America's most dangerous seismic zones. Experts still have no clear explanation. Instead, 4 competing theories point to ancient faults, natural forces, and possible human activity. So, what really caused the ground beneath Texas to suddenly awaken? The Texas earthquake that shocked experts. The early hours of July 23, 2026, in the Texas Panhandle, brought an unexpected jolt that quickly grabbed national attention. At 5:21 a.m., a magnitude 5.1 earthquake struck Roberts County near the small town of Miami, a place better known for cattle ranches than seismic activity. For a region not typically associated with strong earthquakes, this was a genuinely rare and powerful event, shaking the ground hard enough to wake many residents. What made this incident even more remarkable was its size, much larger than the tiny tremors usually linked to human activity like fracking. When people hear earthquake and Texas together, their minds often jump straight to human causes, especially fracking. But this quake defied easy explanations. Typical fracking-related tremors usually hover below magnitude 1, too subtle for anyone to notice without instruments. Occasionally, stronger quakes can happen if drilling intersects with existing fault lines, but a quake this large is exceptionally unusual for the area. It forced experts and media alike to grapple with a seismic event that didn't fit neatly into known categories. Yet, amid all this attention, no clear consensus has emerged on the quake's origin. The event immediately challenged assumptions about the region's seismic activity and raised numerous questions. Was this a one-off anomaly, or a sign of something more complex hidden underground? News outlets were divided. Some labeled it the strongest ever recorded in the Texas Panhandle, while others said it was the strongest in over a century. Conflicting reports made it hard to establish a simple fact: the magnitude itself, because historical measurements were based mostly on eyewitness accounts, not modern instruments. This contradiction adds a layer of mystery to a story already full of surprises. Interestingly, a much smaller aftershock occurred later the same day, hundreds of miles south, stirring momentary confusion about a connection. However, these two quakes were entirely separate geologically, happening in distinct seismic zones within the vast state of Texas. While the initial shock commanded the spotlight, this distant tremor hinted at the varied and complex nature of earthquakes even within a single state, known more for its size than quake activity. The wider context of Texas's seismic behavior is far from simple. What was perhaps most striking to experts was how little anyone expected a quake of this size in such a quiet part of Texas. It wasn't just the shaking. It was what lay underneath that caught the scientific community off guard. This earthquake forced a re-evaluation of the geological landscape, bringing attention to ancient features beneath the surface that had long been overlooked. Yet, for all the data collected in mere hours, the full story still seemed out of reach. Making the mystery deeper, the more it was studied. Those watching closely began to realize this wasn't an event easily slotted into existing explanations. It prompted questions not just about cause, but about how well the region's seismic history was actually understood. Delving into this quake meant unpacking decades, even centuries, of geology and human activity. The unusual nature of the event invited a far-reaching examination that would take more than just seismograph readings. Despite the initial shock, there was relief in knowing no one had been seriously hurt, and no significant structural damage was reported. Still, the sheer strength of the quake ignited curiosity about how often a place like Roberts County might really experience this kind of stress. The area, mostly rural ranchland, seemed an unlikely host for such an event. And yet there it was, proof that the Earth's quiet spots can suddenly roar. This earthquake was not just a headline. It was a puzzle piece in a much larger picture of ongoing geological tension beneath Texas. The questions it raised about regional safety, scientific understanding, and historical record-keeping captured the attention of experts nationwide. As the dust settled, it became clear that whatever explanation might surface, it would have to reconcile old records, new data, and unexpected complexity. More than that, the quake challenged the assumption that some parts of the country are simply immune to major seismic events. It reminded us that Earth's underground forces don't always respect human expectations or settlements, and sometimes they break through where few imagine. This event was just the start of a deeper dive into what exactly lies beneath the Texas Panhandle, and why it might not be as stable as we assumed. Transitions to the next idea often flow from curiosity about location to understanding impact, revealing how a quake felt far and wide. The geography of the epicenter. The earthquake's epicenter was pinned down to Roberts County, nestled in the Texas Panhandle near the Oklahoma border, a place known for flat ranchland rather than seismic activity. This rural area lies closer to Oklahoma cities like Tulsa and Oklahoma City than any major Texas urban centers, which added a unique twist to how the shockwaves traveled. The quake itself was shallow, only a few miles beneath the Earth's surface, which amplified how strongly the shaking was felt over a broad area. Reports confirmed shaking not just throughout the Panhandle, but reaching cities like Amarillo and Lubbock, and even stretching as far as southwestern Kansas and the northern edge of the Dallas-Fort Worth metroplex. Some residents felt the trembling nearly 250 miles away from the epicenter, a remarkable distance for a quake in that part of the country. Descriptions from local towns spoke of an intense rumble resembling rolling thunder, but this thunder was coming from underfoot, not the sky, which struck many as deeply unsettling given the area's usual weather patterns. The quake's shallow depth played a crucial role in how far and wide the shaking traveled. Seismic events closer to the surface tend to transmit energy more efficiently, causing stronger sensations and more noticeable vibrations. This meant people hundreds of miles away experienced jolts and noises that interrupted their early morning routines, marking this as far more than just a localized event. The Panhandle's quiet farmlands suddenly felt connected to a much larger network of geological forces. The morning after the quake, the United States Geological Survey quickly received hundreds of felt reports, reflecting a swift response from individuals watching closely. Seismologists across multiple states zoomed in on this remote corner of the country, an area typically overlooked by earthquake experts due to its historically low seismic activity. Suddenly, the Texas Panhandle was a hotspot of scientific curiosity, revealing that its quiet reputation hadn't meant inactivity underneath. Looking at the geological structure, the region sits atop an old fault system. But for years it had been assumed mostly dormant or insignificant. The wide area affected raised questions about what kind of stress could create such broad shaking from this epicenter. It became clear that the fault was not a new fracture, but an ancient and complex feature that quietly shaped seismic patterns across state lines. Understanding this geography became key to making sense of what really happened. Residents' reactions underscored just how surprising and alarming the quake felt. People described being woken by loud rumbles and ground shaking, sensations foreign even to a region accustomed to severe weather like hailstorms and tornadoes, but not earthquakes. The suddenness and intensity of the event disrupted daily life and challenged assumptions about what Texas could experience naturally. It served as a reminder that while rare, significant earthquakes are very much part of the state's geological reality, understanding the quake's geography laid the groundwork for digging deeper into its history and the forces at play over millions of years. Forces that remain just beneath the surface, waiting for the right moment to reveal themselves. As the physical setting became clearer, the history of seismic activity in the region began to emerge as an important piece of the puzzle. A century of quiet, but not yet silence. At first glance, the Texas Panhandle might seem an unlikely place to host seismic events, but records actually show it's been gently shaking for more than 100 years. Seismologists have documented about 20 separate earthquakes in that same general area since 1907, with some stronger tremors occurring decades ago. This history paints a picture of a quietly active region, contradicting the more popular notion of the Panhandle as geologically still and uneventful. Among these quakes, 3 notable ones surpassed magnitude 5, the threshold that typically draws more attention, happening in 1925, 1936, and 1948. These weren't minor shakes, but significant jolts that likely made their own impact at the time. Smaller events followed in the 1950s, 1970s, and 1980s, suggesting a persistent, though low-key pattern rather than isolated incidents. The recent magnitude 5.1 quake fits within this longer history rather than standing apart entirely. Curiously, some of those older quakes are surrounded by uncertainty because seismographic instruments weren't as widespread or precise back then. For example, the 1930s magnitude 5.4 quake was never directly measured, but estimated from damage reports and personal accounts. This contrasts with modern earthquakes, which can be instantly recorded with high precision. That difference complicates direct comparisons, making it hard to place this week's quake firmly in historical context. The historical record doesn't just provide numbers, it hints at patterns linked to geological features beneath the surface. Several notable past quakes happened above areas with active oil fields at the time, which has sparked conversations about whether industrial activity has occasionally played a role in triggering tremors. However, due to limited data from earlier decades, these remain open scientific questions rather than firm conclusions. Despite its sparse population and wide open spaces, the Panhandle's unsettling seismic backdrop means its calm surface isn't the whole story. This quiet persistence of earthquakes, some reaching considerable strength, quietly challenges the common perception of Texas as a place safe from moderate to strong shaking. Residents might not have noticed, but the earth beneath them has been restless for a long time. This sense of long-term activity connects directly to deeper geological structures that have shaped the region for eons. The fault lines beneath the Panhandle aren't new breaks, but part of ancient, buried features that have quietly borne the brunt of tectonic forces over hundreds of millions of years. Their presence reminds us that the Earth's history is still unfolding beneath our feet. Scientists studying the Panhandle's seismic past are careful to acknowledge the blended nature of natural and human influences on earthquake activity. While some tremors align with industrial development timelines, others seem purely tectonic. Sorting these threads out takes time, and this recent quake reignites the question about how much industry influences such events in this specific part of Texas. Understanding that the Panhandle is not as seismically barren as often assumed provides necessary context for interpreting this recent quake. It dispels the idea that this was a once-in-a-lifetime anomaly, and instead points toward a more nuanced reality of periodic, sometimes sizable tremors spaced decades apart. This helps frame what might come next without needless panic. Taken together, the century-plus record shows a landscape that has been quietly active all along, just beneath the surface of everyday awareness. This realization invites a closer look at what ancient geological forces are still at work below, setting the stage for a deeper exploration of the remarkable scar left by a failed rift beneath Texas. The unfolding story beneath the Panhandle's surface beckons us to understand how ancient scars hold the key to today's unusual quake and the uncertainty that keeps experts searching for answers. The ancient scar beneath the surface. Beneath the calm wheat fields and cattle ranches of the Texas Panhandle lies a geological secret dating back 500 million years. This is the Amarillo-Wichita Uplift, a buried fault system that is not a new crack, but a remnant of an ancient rift where North America once tried to split apart and failed. This failed rift dates back to the early Cambrian period, long before life on land, and its silent presence beneath the region has shaped the Earth's crust ever since. It's a scar left by forces that began shaping the continents when dinosaurs were still unimaginably far in the future. Most people have never heard of this ancient scar because it has remained mostly hidden and inactive for enormous stretches of geological time. But the sheer size and structure of the Amarillo-Wichita uplift suggests it is a major fault system, one that has quietly existed beneath the surface, waiting for stress to awaken it. Its similarity in form to other well-known fault systems hints at a restless underground landscape, one that has the potential to reactivate under the right conditions. This fault is not just a local curiosity. It is a key piece of the seismic puzzle in Texas's Panhandle. The very fact that such a deep and ancient feature sits near the surface helps explain why the recent earthquake's shaking was felt over such a wide area. Unlike deeper, less connected faults, this uplift lies shallow enough to transfer powerful vibrations across hundreds of miles. Its presence challenges the common perception that Texas's Panhandle is geologically stable, instead highlighting a dormant hazard that has been largely overlooked until now. This half-billion-year-old scar carries a weight of history beneath the quiet farmland. Yet, as intriguing as this ancient rift is, it does not offer a straightforward answer. The recent quake could well be linked to this scar, but the story is far from simple. For one thing, stress must build slowly over time to reignite such a system. Tectonic forces shifting continents today are the distant echoes of the ancient rift's violent birth. This means earthquakes like the one in Texas may be the fault finally waking up, but only very rarely and unpredictably, making them difficult to forecast. Geologists face a contradiction here. The Amarillo-Wichita uplift is the obvious suspect, yet the numbers don't fully add up. Historical earthquake data and modern seismic readings don't form a perfectly clear pattern, leaving space for doubt. There are complexities beneath the surface, both literally and figuratively. The fault exists, but exactly how and when it triggers earthquakes is still hotly debated. This uncertainty fuels much of the ongoing investigation and scientific discussion. One reason this scar demands attention is the way it mirrors the structure of another ancient rift, the Real Foot Rift, located hundreds of miles to the northeast. That neighboring rift system is associated with the new Madrid seismic zone, home to massive, legendary earthquakes in the early 1800s. Although Texas is not due for the same intensity of seismic events, the shared geological blueprint suggests a subtle but important connection in the mechanics of deep earth forces across the continent. Despite its age, the Amarillo-Wichita uplift remains a critical factor in the region's seismic potential. It is like a sleeping giant, a scar that still influences the Earth's stress patterns far beyond what might be expected in such a quiet place. This adds a layer of depth to our understanding of the Panhandle, revealing that beneath its superficial calm lies a complex interaction of fault lines and tectonic pressures. For all the mystery surrounding this ancient scar, one thing is certain: it cannot be ignored. Its ability to generate strong earthquakes, though rare, is real and tied directly to the deep geological history of the continent. This puts the Texas Panhandle on a different footing from what many assumed, demanding greater awareness and scientific focus moving forward. While the ancient scar provides a compelling backdrop, it's far from the whole story. 4 key explanations vie to clarify what really caused the recent quake in Texas. 4 competing explanations unveiled. Since the magnitude 5.1 quake shook the Texas Panhandle, scientists have proposed 4 main theories to explain what caused the ground to move that morning. The leading idea is that the ancient Amarillo-Wichita uplift simply reactivated on its own. Over millions of years, tectonic stress gradually accumulates across the continent, and occasionally that pressure finds the weakest spot, this ancient rift fault, and releases suddenly. In this natural explanation, no human activity is involved. It's geology doing exactly what it has done for hundreds of millions of years. The second explanation delves into historical human impact, linking past seismic events in the Panhandle to oil extraction activities. Several earlier earthquakes, including ones in 1936, 1966, 1974, and 1980, occurred above active oil fields where drilling was ongoing. Some researchers suggest these large-scale petroleum operations might have influenced fault stability, potentially triggering tremors. However, scientific limitations from those periods, such as imprecise equipment unable to pinpoint quake depths, mean this connection remains unresolved rather than verified. The third, and most publicly assumed explanation, involves modern wastewater injection related to oil and gas drilling, a phenomenon often tied to increased seismicity in other regions like Oklahoma and West Texas. Pumping leftover fluid deep underground can increase pore pressure along fault lines and induce earthquakes. Yet, officials studying the recent Panhandle quake have been careful not to jump to conclusions. The magnitude is unusually large for a fluid injection event, and so far, the evidence linking this quake directly to such activity is inconclusive. They have emphasized the need for more data before drawing firm connections. Perhaps the most surprising perspective, the fourth explanation, is simply that scientists do not yet know the exact cause. This honest admission reflects the complexity of the event and the limits of current knowledge. Determining what precisely triggered a quake like this takes time. Detailed data collection, modeling, and regional analysis are still underway. In fact, many experts publicly stated within hours that it was too soon to settle on any one cause. Sometimes, science's most accurate answer is a cautious, "We do not know yet." Each explanation has its merits and challenges. The idea of natural tectonic stress reawakening an ancient fault fits the geological context, but doesn't explain all details perfectly. Human influences, whether from historical oil fields or modern injection wells, offer plausible links, but face strong data limitations or lack direct evidence in this specific case. The admitted uncertainty underscores how unique and puzzling this particular earthquake is. This range of theories also shows why no singular narrative can easily dominate news coverage or public understanding. Media outlets have tended to highlight the ones that resonate most with their audience's expectations, whether that be natural geological activity or human-caused triggers, sometimes amplifying confusion. Meanwhile, researchers remain methodical, highlighting the importance of continued monitoring and analysis before jumping to conclusions. Moreover, this debate points to a larger truth about studying earthquakes in regions like the Texas Panhandle. The Earth's underground dynamics are complex, interwoven, and sometimes defy simple answers. Ancient geological formations interact with modern human activities in ways that are still poorly mapped. Each quake offers new clues, but also new questions, pushing scientific investigation forward. With all possibilities on the table and no firm conclusions yet, the Texas Panhandle remains under close watch. The coming months and years will be crucial to untangling this mystery and refining what it means for earthquake risk in the region and beyond. The lingering questions about cause lead us naturally into understanding how often such earthquakes might happen and what risks truly lie ahead. The statistical reality of rare quakes. The recent magnitude 5.1 earthquake in the Texas Panhandle is anything but a random fluke when viewed through the lens of history. Over about the last century, the region has experienced roughly 4 earthquakes of this size or larger. Statistically, that amounts to an event occurring somewhere around once every 25 to 30 years. This frequency challenges the common misconception that sizable quakes are nearly non-existent in this part of Texas. Instead, it reveals a pattern of rare but repeating seismic activity beneath the seemingly calm surface. However, when the threshold is nudged just a bit higher, say to magnitude 5.5 or 5.6, the odds shift considerably. Scientists estimate an earthquake of that strength only strikes this region approximately once every 50 to 100 years. Pushing the magnitude further still to a 6.0 turns this into a truly rare event, roughly once every 3 centuries. These numbers illustrate just how sensitive the scales are. Small differences in magnitude lead to large differences in expected frequency. The 5.1 quake, therefore, sits near the lower edge of what's occasionally expected, but it does not suggest a seismic desert. Understanding these statistical realities puts the recent quake in perspective. It is notable, but not unprecedented. It signals that the Panhandle is not as stable or quiescent as many believe. The region's geological makeup and seismic history combine to produce occasional jolts strong enough to be felt for hundreds of miles. This realization should inform both public awareness and preparedness, even in places that people might consider low risk. The likelihood of another earthquake of similar size or larger occurring within days of the event was calculated by the United States Geological Survey at roughly 2%. While small, that number isn't zero, and it reflects how uncertainties remain in short-term forecasting. Predicting earthquake timing with precision remains beyond current scientific methods, but studies like this help evaluate risk more realistically rather than dismissing it outright. Such forecasts guide emergency planning and public communication. One factor that reduces the overall risk is the sparse population of the affected area. The rural nature of the Texas Panhandle means that even a magnitude 5 earthquake is unlikely to cause major injuries or economic losses on a large scale. This contributes to relatively low damage modeling outputs despite the strength of the quake. Nonetheless, this does not mean the impact of future events should be underestimated, especially if similar activity occurs closer to more densely populated zones. Another interesting point is that the Texas Panhandle's experience with moderate quakes differs from regions like California or Oklahoma, where seismic activity is more frequent and well-studied. Here, earthquakes happen less often, making them harder to predict and less integrated into public consciousness. This rarity can lead to surprises and confusion when a significant quake occurs, highlighting the need for better regional seismic monitoring. Further complicating the picture is how these infrequent events relate to long-term tectonic stress. The slow accumulation of geological forces over decades or centuries governs when and where quakes will strike. In that sense, the recent quake might represent the culmination of stress slowly building and eventually releasing after a prolonged quiet period. This timescale is difficult to reconcile with daily perceptions, but is critical for scientific understanding and hazard assessment. Adding to the complexity is the fact that this region is not geologically uniform. Multiple fault systems and structural features interact beneath the surface, influencing seismic behavior over varied times and locations. This makes drawing exact predictions challenging and emphasizes the importance of sustained research and data collection. Every earthquake adds a piece to this multifaceted puzzle. The history and frequency of these rare quakes naturally bring to mind one of America's most infamous ancient seismic scars, connecting Texas to a broader geological story. The New Madrid Parallel. Deep beneath the Mississippi River Valley lies the New Madrid seismic zone, known for the powerful earthquake sequence of 1811 and 1812. Those quakes were so intense that reports claimed the Mississippi River briefly flowed backward. While the Texas Panhandle does not experience earthquakes on the same scale, the two regions share an important geological feature. Both sit above ancient failed rifts. A failed rift forms when a continent begins to split apart but stops before creating a new ocean. The crust eventually seals, but it leaves behind a deep, weakened scar that can remain vulnerable to stress and movement. Beneath Texas lies the Amarillo-Wichita uplift, while New Madrid rests above the Reelfoot Rift. Though separated by hundreds of miles, both structures were shaped by similar tectonic forces long ago. These buried weaknesses help explain why earthquakes can occur far from modern plate boundaries. Stress may build along old fractures until the rocks suddenly shift, producing seismic activity in places normally considered stable. This reveals that earthquake risk is not limited to obvious fault zones like those in California. However, scientists caution against assuming that Texas is heading toward a new Madrid-style disaster. The 1811 to 1812 earthquakes were unusually powerful and occurred as part of a prolonged sequence. There is currently no evidence that the Texas Panhandle faces an equally destructive series of earthquakes. For Texas residents, The new Madrid parallel should encourage awareness rather than panic. Continued research, stronger monitoring, public education, and basic earthquake preparedness can help communities respond more safely. Ultimately, the connection reminds us that the Earth's ancient scars are not always dormant. They remain hidden beneath the landscape, quietly influencing where future earthquakes may occur. With these insights framing the story, the question remains: what will the future hold for Texas and its ancient faults? What happens next in Texas? After the magnitude 5.1 earthquake, the United States Geological Survey estimated there is about a 2% chance of another quake of similar size or larger in the coming days. While the odds are low, scientists continue monitoring the region because earthquakes remain difficult to predict. Fortunately, the epicenter was in a sparsely populated part of the Texas Panhandle, so damage was limited and no major structural losses were reported. Still, the quake highlighted how different the outcome could be if a similar event struck a more densely populated area. Researchers stress that this earthquake is not the end of the story. The Panhandle sits above ancient fault systems that remain capable of producing seismic activity. Seismologists are closely tracking aftershocks, expanding monitoring networks, and sharing data to better understand how these faults behave. One of the biggest challenges is uncertainty. The ancient Amarillo-Wichita uplift fault system operates over geological timescales, making it impossible to predict exactly when another earthquake might occur. Although wastewater injection has been linked to smaller quakes in parts of Texas, there is no clear evidence that it directly caused this stronger event. So investigations remain ongoing. Beyond the science, the earthquake has changed how many people view seismic risk in Texas. It serves as a reminder that significant earthquakes can occur in places long considered stable. As researchers search for answers, officials continue encouraging preparedness and monitoring, because while another major quake is unlikely in the near future, it cannot be ruled out. This Texas earthquake revealed a hidden chapter in America's geological story, showing us that ancient faults still hold surprises today. Whether natural forces or human activities are responsible, one thing is clear: the ground beneath us is more dynamic than we often realize. If you found this deep dive fascinating, please like and subscribe for more stories that uncover the unseen forces shaping our world.